Class, our today's new topic is audible sound. So audible sound means class, when we are talking about sound, we are talking about the specific frequencies of sound which we can hear. So there are some specific kind of frequencies which we, the human being, can hear, but there are so many frequencies which we are not able to hear. So we can hear the sound of frequencies between 20 Hz to 20,000 Hz. All the frequencies we can hear, but we cannot hear class the frequencies below 20 Hz and the frequencies above 20,000 Hz. And you all know the meaning of frequency class. Frequency means the vibration in 1 second. It means class, if there is a vibration which are less than 20 in 1 second, then we are not able to hear those sound. And if the vibration are too much high, it means in 1 second if there are more than 20,000 vibrations, then at that time also we are not able to hear that sound. Next topic is ultrasonic sound. Sound of frequencies higher than 20,000 Hz are called ultrasonic sound. We cannot hear ultrasonic sound, I told you earlier, but some animals like dog, bats, monkeys, deers, leopard, etc. can hear ultrasonic sounds. And class, dog can hear sound of frequencies up to 50,000 Hz. It means class, if there are 50,000 vibration in 1 second, dog can hear those sound also. Bats can hear the sound frequencies up to 1 lakh Hz. So bats class can hear the sound of frequencies of 1 lakh Hz. So use of ultrasonics by bats. How bats can use the ultrasonic wave or ultrasonic sounds. At night, bats easily move about without colliding with any object or obstacles. The reason is that they produce ultrasonic sound. It means class, bat produce ultrasonic sound. It means they produce the sound which are more than 20,000 Hz as they fly. When this ultrasonic sound comes back after reflection from any object or obstacles in their way, they hear it and thus they detect the presence of the object or obstacles and change their path. So class, if I am talking about bats, when they produce sound which are ultrasonic sounds, and those sounds when reach to this pole, then after striking the pole they reflect, and in this reflected sound this bat can assume how much far this pole from me, and he can visualize that pole through those sounds and he can not touch the pole. So there is a very special kind of functioning he is using to find the obstacles. So class, our next topic is infrasonic or subsonic sound. So sound of frequency lower than 20 Hz are called infrasonic. So 20 Hz means class 20 vibrations in 1 second. So we cannot hear those infrasonic sounds. For example, the pendulum of a clock make one vibration in 2 seconds. So if one vibration in 2 seconds, the meaning is in 1 second it has only 1/2 vibration, which is very less than 20. So we are not able to hear that sound. The frequency of sound produced due to its vibration in 0.5 Hz. So 1/2 Hz means class 0.5 vibration, and 0.5 vibration means 0.5 Hz. So this is the frequency of that pendulum. It is infrasonic sound and hence we cannot hear it. So now class, characteristics of sounds. There are two characteristics, loudness and pitch. So what is the meaning of loudness? The loudness of a sound depends on the amplitude of vibration of the vibrating body producing the sound. So class, it's very important, your loudness depends on the amplitude. And class, what is amplitude? So class, here you have two figures. In first figure this is your amplitude, in second figure this is your amplitude. But before that, what do you understand by amplitude, class? Amplitude means the displacement of wave from its mean position. So if this is the mean position, then this is the displacement of this sound wave, and here this is the displacement of this sound wave. So class, if I am talking about these two, whose amplitude is more? So class, definitely in this second figure, the amplitude of this second figure is more, because it displaced so much from the mean position. So here your amplitude is so much high. So if your amplitude is high, then your sound is louder, and that is loudness. It means class, your loudness depends on amplitude. More the amplitude, more is your loudness. Less amplitude, less loudness. So class, to understand amplitude, if I am talking about guitar or sitar, suppose these three are the strings, and we just take the example of these strings. We plug these three strings, and when we plug these three strings, then at that time, suppose this string vibrates like this string vibrate like this, and this string vibrates like this. Then in this time, class, you can see the vibration. Amplitude means, class, when this string vibrates, how much up and how much down it goes. So class, when we plug the string, at that time this kind of vibration is there. So you can see here you have a very small vibration, but here you have a very big vibration, and here you have a medium size vibrations. So class, if you have a very less vibration, then you can say your displacement of wire is very less, so your amplitude is very less. Here your amplitude is, your displacement of wire is too much, so your amplitude is too much high. And here after this is your, in first string, this is your amplitude. So you can figure out, class, this has a very low amplitude, so it has a very, so the loudness of this third figure is very less. After that, the loudness of first figure is a little bit high than third one. And who is more louder? So it is louder than all of them. So your loudness is depend on the displacement, or we can say the amplitude of wave. Now it's very important, class, your loudness also depend on area. It's very important. If I'm talking about drums, this is a smaller drum, this is bigger drum. Who produce more loud sound? Obviously in schools you can see the bigger drum produce more loud sound. It means if the area is bigger, then sound is more louder. So loudness depends on area. If your area is high, your loudness is also high. This is your area is less, loudness is less. Now class, next topic is pitch. Pitch is the high or low frequency of sound. It means, class, your pitch depends on frequency. The pitch of a sound depends on its frequency, or we can say number of vibration produced per second by the body. So class, what is the meaning of frequency? Vibration in 1 second. It means if I am talking about 1 second, suppose from here to here total time is 1 second. So if this is the frequency, or we can say this is the vibration of any wave, and here this is the vibration. So you can see, class, this is your one vibration I told you earlier, this is your second vibration, and this is your third vibration. So you have 3 vibration here. So in 1 second you have 3 vibrations, but here you have 1, 2, 3 and 4 vibrations in 1 second. So if you have 4 vibration in 1 second, then you can say your frequency is 4. Here you have 3 vibration in 1 second, so your frequency is 3, and the unit of frequency is hertz. So it means class, in 1 second the number of vibration give you the frequency. If number of vibrations are 4, 4 is your frequency. If number of vibrations are 3, 3 is your frequency. And your pitch depends on frequency. So it means class, if I am talking about 4 hertz and 3 hertz, whose frequency is more? 4 hertz. So 4 hertz is more than 3 hertz. So your pitch is depend on frequency. So if your frequency is more, your pitch is high. So class, your pitch depends on frequency. If your frequency is high, your pitch is high. If your frequency is low, your pitch is low. Here class, very less vibration as compared to B. So this has a high pitch and it has a low pitch. So this has a higher pitch, this has a lower pitch. Higher the pitch, shriller the sound. So class, if your pitch is so high, your sound is shriller. So class, higher the pitch, shriller the sound. It means if your pitch is too much high, then your sound should be shriller. But if the pitch is low, the sound is flat or grave. The voice of a girl shriller than that of boy because the voice of girl has more frequency as compared to boy. So this shows the frequency of girl's voice and this shows the frequency of boy's voice. So class, यहाँ पर एक एक्टिविटी दी हुई है जिसमें आपके पास 4 टेस्ट ट्यूब हैं, और अगर मैं फ्रीक्वेंसी या फिर फ्रीक्वेंसी ऑफ साउंड की बात करूं, जब आप अपने मुंह से हवा अंदर डालते हैं तो यहाँ से हवा कुछ इस तरह से बाहर आती है क्लास। वहीं जब आप पानी को थोड़ा ऊपर बढ़ा देते हैं, हवा का एरिया कम हो गया है, तो अब हवा से जब आप फूंक मारेंगे तो हवा थोड़ा इस तरह से बाहर आएगी, और जैसे जैसे अब यहाँ पर हवा के लिए जगह कम बचती जाएगी तो क्लास हवा ज़्यादा श्रिलिंग मूवमेंट करेगी, और यहाँ पर क्लास हवा कुछ इस तरह से आएगी। सो क्लास, आप खुद ही देखेंगे कि यहाँ पे चारों में जब आपके पास एयर स्पेस ज़्यादा था तो आपकी हवा आराम से बाहर आ रही थी, लेकिन जैसे ही हवा के लिए आपको जगह कम मिलनी शुरू हुई तो आपकी हवा ने श्रिलिंग करना शुरू कर दिया। इट मीन्स क्लास, यहाँ पर आपकी हवा जहाँ पे ईजिली बाहर आ रही थी तो मोटी आवाज़ आएगी, धीरे धीरे यहाँ पे आपकी पिच बढ़ती जाएगी क्लास, और यहाँ पर आपकी पिच सबसे ज़्यादा हाई होगी। इसका मतलब क्लास, जितना कम जगह हवा को बाहर निकलने को मिलेगी उतनी ज़्यादा पिच हाई होती जाएगी। एंड नाउ क्लास, इन musical instruments like flute and clarinet, the pitch of the sound is changed by changing the length of the vibrating air column. It's very important class. So where are those air columns? So class, if I am talking about clarinet or flute, I just take the example of clarinet. From here we blow the air, and if we close all these three, suppose I close these three here, then you have only this point from where your air can come. So this is your distance for producing sound. And class, if I also cover this, then your air travel this distance in this time. So it has a different kind of sound, because class, the frequency of sound is changed. When your air comes out from here, the frequency is different. When you plug it, then at that time the frequency is change in this time. And now class, if you close these two and also this, then in this time there is a different kind of frequency. For this there is a different kind of frequency, because it depends on the distance, as I told you earlier in previous activity. So it's very important class, when we plug these holes, then the frequency is changed continuously, and that's why different kind of sounds are produced by clarinet or flute. In stringed instruments such as guitar, sitar, piano and violin, the pitch of sound can be changed in two ways. So how we change pitch in these stringed musical instrument? First, by changing the place of plucking or striking on the string. It means class, where we strike the string, from that we have to change the frequency, or we can say we have to change the pitch. It means class, if this is your guitar string, then if I press here or plug here, then different sound is produced. If I plug here, different kind of sound is produced. So class, in guitar you all know string is there, but for our finger movement we have to press sometime here, sometime here, just because when we press these portions, at that time the tension is प्रोड्यूस्ड इन द स्ट्रिंग्स, और उसके कारण से क्लास जब भी आप प्लग करते हैं किसी स्ट्रिंग को किसी स्पेसिफिक प्लेस पर, तो उसका साउंड डिफरेंट हो जाता है. सो क्लास, इफ दिस इज योर गिटार, सो हाउ यू चेंज योर पिच? इट डिपेंड्स ऑन टू थिंग्स. फर्स्ट इज वेयर यू प्लग द स्ट्रिंग. इसका मतलब क्लास, आप किस जगह पर अपना स्ट्रिंग पे हाथ मारते हो. सो इफ यू प्लग हियर देन डिफरेंट साउंड इज प्रोड्यूस्ड, इफ यू प्लग हियर then different sound is produced, if you plug here different sound is produced. And second is how you create tension. So class, you can use your fingers to produce tension. So class, it's important, when you press your wire in this point, then different kind of tension is here, so different kind of sound is produced. When you press your string here, then different kind of tension is there, so different sound is produced. So for string musical instrument, there are two ways by which you can produce sound, or you can produce different kind of sound. And class, our next topic is speed of sound. So class, we have read that sound cannot travel in vacuum. It can travel only in medium, whether solid, liquid and gas. So yes class, sound need medium to propagate, and in different medium different kind of speed sound has. So it's very important that what is the speed of sound in different medium. So class, sound has approximately 330 meter per second speed in gas, 1500 meter per second speed in liquid. In solid, they give you the example of iron and steel. In iron, the speed of sound is 5100 meter per second, and in steel it's 5960 meter per second. It means approximately 5000. So class, with the help of this table you can understand the speed of sound is maximum in solid. After that, the speed of sound is good in liquid, and at last the speed is very slow in gases. And class, in our surroundings or in our daily life, we hear most of the voice in air. So in air, the speed of sound is 330 meter per second. So class, next topic is reflection of sound. So class, you all know the law of reflection of light. So sound also obeying the same rule. So the reflection of sound takes place obeying the two laws of reflection. Those two laws are the angle of incidence is equal to the angle of reflection, and second is the incident sound, the reflected sound and the normal are in the same plane. So class, this is the figure which we normally use for law of reflection of light, but here it is also used for law of reflection of sound. So you all know this is your incident ray, and after striking the surface the sound is reflected. So this is your angle of reflection. So all the time your angle of incidence is equal to the angle of reflection. Suppose class, this angle is 30 degree, so definitely this angle is also 30 degree. It means if your sound comes in this surface in 30 degree, then it is reflected also in 30 degree. And the second thing is, this is your normal. So class, suppose this figure is this. So in this time class, you can see this is your normal, this is your incident ray, and this is your reflected ray. So this is angle I and this is angle R. So class, when your incident ray, reflected ray and normal are in same plane, then we can say this obey the law of reflection. So class, if I'm talking about this, then they all are in the same place. Same plane means class, if I'm putting a plane like this, then they all are in the same plane. Suppose this is the plane, so they all are in same plane. They are not like this class. So they all lie in the same plane means they are in this plane. They are not here and there like this. So this is the meaning of same plane. Hope you all understand class. So this is the activity which is based on reflection of sound. You can read that. Now echo. You might have experienced that if you stand closer to a well facing the water or at a large distance from the wall of a big empty hall or a hillside and produce a sharp sound, you will hear two sounds, the original sound and the other sound after a fraction of second. The second sound which is heard after some time is the sound produced after reflection from the water in the well or from the wall of the hall or hillside. This sound is called echo. So class, that repeating sound is normally known as echo, and it is just because of the reflection of sound. I told you, I explained you the reflection of sound. So echo is the distinct sound heard after reflection from a distance, rigid surface such as a cliff, hillside or the wall of a building, etc. And now this is very important part class. To hear echo, the sound after reflection from the rigid surface should reach the ear at least 0.1 second after the original sound is heard. This is because the original sound persists in the ear for about 0.1 second. If the reflected sound reaches the ear before this interval of time, it will intermingle with the original sound and it will not be possible for us to distinguish the two sound. So class, why there is a difference of 0.1 second between the original sound and reflected sound? To understand this, let's check this. We know that the speed of sound in air is 330 meter. So what is the meaning of 330 meters per second class? So class, try to understand this. Speed of sound in air is 330 meter per second. So class, if I am talking about echo, so echo means you need the reflected sound also. So definitely class, if you have a two sound, if first sound is in first second, then definitely the next sound at least takes a 0.1 second. Yes or no class? So in 0.1 second, sound travel or sound cover 33 meter, because in 1 second it cover 330 meter. So in 0.1 second, 0.1 second means class 1 upon 10th of second. So in 1 upon 10 second, or we can say 0.1 second, it cover 33 meter. It means class, for echo at least you need 33 meter of distance. But it's very important class, if you produce sound from here and it goes there, it covers 33 meter, then it comes back, so it's actually 66 meter. So it means you need 16.5 meter distance. So when you speak or you loud, at that time the distance is 16.5, and when sound reflected, then also it covers 16.5. It means it is approximately 33 meter. So to hear echo, at least you need 16.5 meter distance between you and the obstacle or the surface by which the echo will formed. And now absorptions of sound. When sound falls on sofa, fluffs and light substance such as clothes, paper, thermocol, coating of plasters of Paris, carpets, curtains, furniture, wood, etc., it is absorbed to a good extent. These substances are called good absorber of sound. And a soundproof box means an enclosure such as theater, auditorium, etc., which does not allow the internal sound to come out and external sound to enter in. In order to design such a box, we take the following measures. So how we create soundproof room? The roof of the enclosure must be covered by the plaster of Paris after putting the sheets of thermocol. The walls of the enclosure should be covered by the wooden strip. The floor must be laid down by a thick carpet. The machine parts of all the electrical equipment such as fan, air conditioner, etc. must be placed outside the enclosure. Thick curtain should be used to cover the door and keep them closed. Thick stripping must be used to cover the opening of the doors and windows. So class, with the help of these points, we can make a soundproof room.